Hello guys, this time I'm going to explain about the exercise 7b, which is related to number sequence with geometrical figures. Let's say number 1, the first 4 figures of the sequence as shown is this. Figure 1, we have 1 circle here. Figure 2, 2 circles. Figure 3, 3 circles. Figure 4, 4 circles, whereby the number of intersections is shown here. Figure 2 has 1 intersection. Figure 3 has 2 intersections. Figure 4 has 3 intersections. So draw the next 2 figures of the sequence. That means we are supposed to draw figure 5. Figure 5 will have 5 circles, of course, and with 4 intersections. While figure 6 will have 6 circles with 5 intersections. That's pretty easy. So what about 2? Copy and complete the tables. So we can see here from the first figure number 1, the number of intersection is 0. There is no intersection there. Figure number 2, there is 1 intersection. Figure number 3 is, as we can see in figure 3 here, the number of intersection is 2. Figure 4, there are 3 intersections. Okay, as we can see here, and figure 5, based on what we have drawn here, we have 4 intersections. Figure 6 has 5 intersections. So now if we can see a pattern here. If the figure number is 1, so the number of intersection is always 1 less than figure numbers. So as we can see here, figure number 1, the number of intersection is 1 minus 1, so it's equal to 0. If the figure number is 2, that means the number of intersection is 2 minus 1, that's equal to 1. If the figure number 3, okay, the number of intersection will be 3 minus 1, that's equal to 2 intersections. So if the figure number is n, okay, that means the number of intersection is n minus 1. Now, find the value of n, for which the circles in the figure have 28 intersections. That means if over here is 28, okay, over the figure number will be 1 extra, that means 29. So the answer for this is figure number 29. Now let's move on to number 2. The first 4 figures of the sequence are as shown as this. So figure number 1 you see is 4 small triangles. Figure number 2 has 9 small triangles. Now figure number 3, okay, we can count here the number of triangles. That will be 16. Figure number 4, the number of triangles will be 25. Okay, 25. Now, you know that this 4, 9, 16, 25 are perfect squares or square numbers. 4 stands for 2 power 2. 9 is actually 3 power 2. 16 is actually 4 power 2. Well, 25 is actually 5 power 2. So, now, what about this number of triangles, small triangles for figure number 5? Okay, one way you can try to draw the figure number 5, or the second way is you try to find the patterns. Now, let's try to find the patterns here. If the figure number 1, the number of triangles is 2 power 2. If the figure number 2, okay, the number of small triangles is 1 extra of 2, that means 3 power 2. Okay, figure number 3, the number of small triangles is 1 extra, and then you square it. 1 extra of 3 is 4, so 4 then you square it, that becomes 16. Okay, that means if figure number 5, okay, number of small triangles will be 1 extra of 5 is 6, and then you square it, so that will become 36. Right? And then if the figure number is 6, that means the number of small triangles will be 7 squared, or equal to 49. That means figure number n, number of small triangles will be n, you add by 1, and then use bracket, okay, then you square it. Okay, next. Find the number of small triangles in the 20th figures. That means the n is 20. Okay, n is 20. Okay, we know that the formula for the number of triangles is actually n plus 1, you square it. That's how to get the number of small triangles. That means we key in that n value is 20, so 20 plus 1. Okay, and this will be squared. That will become 21 squared. Alright, so 21 squared is 441. Okay. Next, Find the value of n for which the figure has 1 to 1 small triangles. We delete this one first. Find the value of n for which the figure has 1 to 1 small triangles. That means n plus 1 squared is equal to 1 to 1. And we know that 1 to 1 is actually 11 times 11, or 11 squared, equal to 1 to 1. Okay? That means the n here, this 11 squared equal to 1 to 1. That means the n value here will be 1 less than 11, so the n will become 10. Next, will there be a figure in the sequence that has 2,400 small triangles? So we key in the formula, which is n plus 1 squared, that's equal to 2,400. Now we know that 2,400 is actually not a perfect square, or if you try to find the square root of 2,400, what is the square root of 2,400? You can just use a calculator here. 2,400, that's equal to 48.99. 48.99. So it is not a whole number, so 2,400 is not in the sequence. Because, okay, it's not a whole number here.